Hello guys, in last video we saw a small example of Networkx, how we can create smaller graphs and how we can visualize them using our matplotlib library. So in this video we'll see some more of Networkx, and then we'll see how to generate graphs in a new format as a file which is known as GEXF format, and then we will use a new tool known as Gephi to see and visualize the graph. And there are so many other things which you can do with the Gephi tool. So let's see this. So again I will let me clear my IPython console. Okay, let me make a basic graph, a random graph using GEXF format. Networkx. So I'll write the command to create a random graph was nx.gnp random graph. It's coming here, and I'll just put my number of nodes and the probability with which I am putting edge between two nodes. So let me put some more number of nodes so I can see something. Let me put number of nodes as 50 and probability be, let's say, 0.3. Okay, great. Let me just see this graph once. So matplotlib I have imported. Okay, so I'll put nx dot draw my, I'll save this graph as g. I didn't save it. Okay, g is equal to my this, and I will draw this graph. After that I'll show this graph. Great, let me see this, let me run this. Okay, you can see it's very dense because the number of nodes are more and the probability is okay, 30%. With 30% probability I am adding edges. It's not a complete graph, it looks like a complete graph, but it is a random graph. Okay, let me do some more things with this graph. So let me go to my IPython console. Okay, let me make it side by side so that it is visible. Okay, what I am going to do, I am going to just print number of nodes here. Sorry, not the number of nodes, the nodes. So this is g dot nodes. Okay, these are my nodes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 up to 49. It starts with 0. So let me, it's coming as a container, so let me print it. Print g dot nodes. Okay, now it is a list. So this is the list of all nodes which are present in this graph. Same way I'll print the edges. So print g dot edges. Okay, it has printed the edge list between which node is connected to which node. For example, you can see here 0 is connected to 3, 0 is connected to 5, 0 is connected to 8, 0 is connected to 10, 0 is connected to, and so on, something like that. So now I can do a lot of things here. You can see the edge list here. Suppose I want to know the degree of each node, so I can just print it here as print g dot degree of, let's say, 0. Show me 13. 0 has 13 degree. So something like that I can do with this graph. I can analyze a lot of things. You can see, you can go to the documentation and you can see there are a lot of things here. There are a lot of functions, lot of algorithms, lot of graph types. Just explore it. What I'm going to do, I will generate one more different type of graph here, which is known as scale-free graphs, which was given by Barabashi. So I'm going to generate it, which is, you do not have to know what exactly it is. I just wanted a new type of graph which is different from random graphs. That's why I'm generating it, so that I can show you the difference. So I'll just generate this, let it be here. So I will generate this scale free graphs. So it is nx dot, the command is Barabashi Albert graph, Barabashi Albert underscore graph. Okay, it takes two arguments. One is n, number of nodes, okay, and second is m. M means each node is coming up with two edges. So how it works, in the starting there are very few nodes. For example, there are 2 nodes, and then at each iteration a new node comes, and whenever this new node comes, it comes with 2 edges, and these 2 edges, it gets connected to those node which has higher degree. So the probability of getting connected to already existing node is higher for that node whose degree is very high. So this why this process this process happens, and at the end you will see that the node which is having higher degree at the end will have more degree. So, and there will be very few nodes of having very high degree and very high number of nodes having very low degree. So this is known as scale free graphs. So I'll put this, and I'm sorry again I'll put this 50 here, and m as 2. Each node is coming up with 2 new edges, okay, and I'll see how it is different from this node. Okay, I'll just run this. You can see it's so different from this GNP, I mean the random graph. Now why is it? You can see there are few nodes, 1 to these nodes which are closer to the center are having high degree, and these nodes which are at the periphery are having very less, some as low as 1. This is a connected graph. You can see all nodes are connected, but very few nodes are having a high degree, and very large nodes are having low degree. So this is known as preferential attachment. New nodes, when they come, they prefer to attach to old nodes which are having higher degree. So it is known as that in real world examples, many nodes are not exactly random. Most of the networks are not exactly random. They are actually scale free. People have claimed like that. So what our aim is now, this graph what we have generated, we'll see this graph in a new format. We'll write this graph in a file, and the format of that file will be GEXF. So to do that, what I will do, okay, so I have to write this graph. I have created the graph. So after this, I will just write a statement to write a graph in GEXF format. The command is nx dot write underscore GEXF. You can see it's there. GEXF is my format. The first argument will be my graph, which is G, and the second will be the path or the file name. If you are not giving the path, the file will be saved in your current directory. I'll just put the name as analysis1 dot GEXF. That's it. Okay, great. I will run this again. The network has been created, and you can see the if I go to my directory, you can see that this file has been created. If I just open it, let me just open it with my Sublime text. You can see some format is there to represent this graph in some XML. This is some XML format. If you try to see this, you can see that there are nodes with some ID and with some label, and then there are edges with some ID and source from where to where it is. Okay, And so this is how this is some XML format. So my graph has been created in GEXF format. Why I am doing it? This GEXF format I am going to import in a new tool known as Gephi. Gephi is a application through which you can visualize graph easily, and you can do a lot of different kind of analysis in one click. So I've already downloaded Gephi in my computer. It's very easy. Just Google Gephi. The first link with Gephi download, the first link you get, go there and just download it. Nothing else is required. Maybe Java 1.8 is 1.7 or 1.8 is required, that you can download easily. Nothing else is there. Just download it. I have already downloaded it. If you require, if you are facing any problem with Gephi, just let us know or put it on discussion forum. We'll show you. So I am going to skip that download part of Gephi. I'll just open Gephi in my system, and I'll see this graph. I will analyze this graph or visualize this graph. So this is my Gephi, the newer version 0.9. So I'll just go to file and open my graph which I just created on through my Networkx, which was a Barabhashi Albert graph. So this is my graph. Okay, analysis 1. I'll just open it. It's showing. See how many number of nodes are there. 90 number of edges are 96. It's asking me what kind of graph it is. It is undirected graph. I'll just put OK. You can see the graph is there. I will just zoom it using my scroller. Okay, I'm on Windows. On Mac it's things are different, and on Ubuntu also a little bit things are different. So you can see this is my graph. Okay, now let me show you a very unique thing here. You can put any node and you can change the direction of the nodes very easily here, and you can see how many to which node it is exactly getting attached to. This T is the level. If I put this, it will show me the node levels. So this is node number. This is my node number 1. There are some plugins which I will show you what exactly it is, but just don't worry what I am doing. I'll just relabeling things. Okay, that's it. So I'll just unlabel it so I can see the nodes. Now what I want, I told you that in this graph, in this particular graph which is scale free, so there are few nodes which has higher degree, and there are a lot of nodes which are having lower degree. So what I'm going to do here, you can see this button. Follow my cursor. This is my button. This is showing the node color, and this is size. So what I'm going to do, I will change the color according to the degree. How will I do it? I'll go partition, not ranking. I will do the ranking. Choose the attribute as degree, and I'll change the color here as, let's say, which color is easily distinguishable. Let's say this. Okay, and I'll apply. You can see these are the dark nodes. Let me just zoom it. The dark nodes are those nodes which are having higher degree. You can see there are so many nodes which are light. Now still it is not very much visible or comfortable. So what I'm going to do, I will change the size of the nodes based on, again, degree. Min size I'll put, let's say, 10 here, and max size I'll put as 20. Now let's see what happens. See, let me make it 20 and make it 40. It's clearly visible. Now see, you can see exactly here there are very few nodes which are very big, and a lot of nodes are smaller. Okay, so such kind of easy visualization, if you want to just analyze your network through eyes and see what exactly is going on, you can do such kind of thing on. There are so many things which you can do. One more thing I will show here. You can see, follow my cursor, and you can see there are so many layouts. What is this? I'll just put this and just run it. You can see the nodes are reassigned in a circular way. This way you can see a lot of things and you can analyze graph very easily. I will just increase the size of nodes, edges, so that it is visible. Now see the right pane. On the right side there are so many things which you can do. For example, I want to see the average degree. I'll run it. It will show me the degree distribution. If you see the degree distribution here, see the points here, you see that there are very few nodes which are having very high degree. There is one node, exactly one node having 18 degree. There are so many nodes of degree 2. There are 24 nodes of degree 2. So this is what scale free network is. It follows something like this, or it is known as power law. This is known as power law. You can read more about this. What else you can do? You can run this network diameter, and in one click, and for undirected, in one click you will see the diameter here. The diameter is 4. There are so many things which you can do. You can run the page rank value modularity. So I'm not doing it because we don't understand it properly. I mean, it's very basic. I wanted to show a very basic thing, how to create a graph in Networkx and visualize it using your GEXF format. You can even using this data laboratory, you can import or export this graph in a spreadsheet or see comma separated value. We have talked about this comma separated values in GPS fun activity. You can import it a comma separated value file and then visualize it. You can even preview your network through this. You can see a very beautiful network has been created here, where the edges are curved. You can save your network as PDF, and you can do a lot of things here. So this, I just wanted to give you a quick introduction to this very beautiful tool known as Gephi, GEPHI, and you can just download it. You can see in our next choice, which is network analysis, actually 6 degrees of separation. You will see what exactly it is. You'll see you'll see the importance of network in our life, and I just wanted to motivate you with this visualization tool, how sometimes it is very important to see things and before just getting into the coding and writing functions to analyze it. Just sometimes you need to watch things closely and then see what exactly is going on. So you can see this is extremely good. You can do a lot of things with this tool. So please, if you have any problem, if you are facing any problem with that Gephi download, please post it on forum, or we can put a quick video to download Gephi, how to download Gephi, how to install Gephi. So thank you.